The last topic we're going to cover within this lesson is how to actually use your chart. In this course, you'll be expected to plot on paper for a few assessments as well as a couple of our navigation simulators. Understanding some basics on how to use your chart will help you in these exercises. The first thing to consider is which hemisphere are you in? By looking at the latitude and longitude on your chart, you'll be able to determine which hemisphere you're in. For this example, right now we're specifically looking at longitude. We see on this chart of Narragansett Bay that our minutes of longitude are increasing from right to left. This tells me that I'm in the Western Hemisphere. This example of Guam, our minutes of longitude are increasing from left to right, telling me that I'm in the Eastern Hemisphere. The best way to think about this is where are you in relationship to the prime meridian? The prime meridian is 0 degrees of longitude. Everything to the east of the prime meridian, the numbers will increase from left to right. Everything west of the prime meridian, the numbers will increase from right to left. The same is true for minutes of latitude. Picture yourself in relationship to the equator. If you're in the northern hemisphere, your minutes of latitude will increase. And if you're in the southern hemisphere, your minutes of latitude will decrease. Next, I want to determine how I'm going to use my latitude and longitude on this particular chart. Some charts are designed that you can measure latitude and longitude in degree minutes seconds or degree minutes tenths. This is one such example. This chart from 21 degrees 22 minutes to 21 degrees 23 minutes, increasing, therefore I know I'm in the northern hemisphere, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ticks between each minute of latitude. Meaning I can read this point of latitude as either 21 degrees 22.1 minutes north or 21 degrees 22 minutes 6 seconds north. On charts where there are 10 ticks between each minute of latitude or longitude, I can read the chart as degrees minutes tenths or degrees minutes seconds. And because there are 10 ticks, 10 divided by 60 seconds within that minute means each one of those ticks is 6 seconds. Additionally, I also have those 6 individual seconds broken out here, so I can measure seconds very precisely on this chart. Some charts are only designed to be used as degrees minutes seconds. This chart here on the left, we see that there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ticks between each minute of latitude. And it would be the same for longitude. This chart, we have 1, 2, 3, 4, 5, 6 ticks between each minute of latitude or longitude. Just like with the previous example, we do have the individual seconds broken out somewhere on that scale, allowing us to be very accurate. But anytime there are more or less than 10 ticks between each minute of latitude or longitude, those charts can only be used as degrees, minutes, seconds. Finally, we see something common for small scale charts. Let's look at this example a little more closely. Here, I have 22 degrees, 10 minutes, 22 degrees, 11 minutes, 22 degrees, 12 minutes, 13, 14, 15. So each one of these sections is a minute of latitude. And within each minute of latitude, there are still 10 ticks. But because this is such a small scale chart, each one of these small areas also represents 6 seconds. And on a scale this small, it can be very difficult to measure those seconds accurately. It might be more common to see this scale of chart used as degrees, minutes, tenths. But technically, you could use it as degrees, minutes, seconds. It's just more difficult because the scale is so small. The last thing to talk about are the tools that you'll be using in this course. Every tool is designed to be used for a specific task. If you use the right tool for the right job, it's going to allow you to be more accurate. First, we'll look at our dividers. Dividers are meant to measure latitude and longitude and can also measure distances. Ideally, you would not try to measure a distance with a divider that is larger than the divider itself can spread. If you did have a distance farther to measure than the divider would allow, you would use a tool called a beam compass. The beam compass allows you to measure much larger distances in one go. The key here being the fewer times you have to move your hand to measure one single distance, the less error that might be invited into that measurement because you're doing it all in one shot. The next tool to talk about are triangles. Triangles will allow us to measure lines of position or any bearing line on our chart. We can use the triangles with the true degrees on the compass rose, but we can also measure lines of bearing on lines of longitude. During this course, we will give you a tutorial on how to properly use triangles. Similar to the triangles are a rolling straight ruler. You may be a little bit more familiar with that tool. You'll be provided with those as well in this class. They perform the same function as a triangle. Finally, similarly to how the beam compass allowed us to measure one distance without having to move our hands multiple times, a yardstick can allow us to do that with lines of position that are very far away from our position. The reasoning here, again, is that the fewer times I have to move my hands, the less error that might be invited into my measurement. That was just a brief overview of getting familiar with the chart and how to use it. We'll go into a lot more detail when we do the chart labs within this class. Wrapping up all the topics we talked about within this lesson, the nautical chart, we covered geodesy, how geodesy allows us to have navigational datums, which navigational datum we use, and how it helps us in navigation. We learned about chart fundamentals, what great circle routes were, how to verify the chart scale and accuracy, how to read the items on our chart and its numbering, and correct chart usage. Please make sure that you bring any questions that you may have had during this lesson into class with you.